To help you get more comfortable with proofs in the natural deduction system, we're going to look at 3 more examples, and I'll talk some about strategy and illustrate our new proof rules as well. This first example is going to illustrate modus tollens and double negation elimination, and we'll also see a little subproof for introducing double negations, though that's not a particular rule we're going to use. So the argument we're looking at is a valid argument, and we're going to prove that. So the premises are if not A, then not B, and B. And from that, we're supposed to prove A. So I've set up the basics of our proof with our premises as the first 2 assumptions and our reminder of our conclusion. And where should we go from here? Well, we can't use B to apply any rule to 1. Well, B is not the negation of not B, so it doesn't allow me to directly apply modus tollens. But if I could somehow get not B, I could use modus tollens here. And we have a rule that would allow us to get not B. If we assume not B for negation introduction, we can use that to add an additional negation. And this is a very short proof. Anytime you want to add a double negation, you just assume the negation of a sentence that's already appeared on your tree. That gives rise to a contradiction. And that's justified every time you introduce a contradiction, negation elimination on the lines that contradict each other. So that's 2 and 3. And then that already closes our subproof and allows us to infer not B. And that's by negation introduction across the subproof that goes 3 to 4. Now we have the negation of the consequent. So we can apply modus tollens and get not A. So modus tollens says if we have the negation of the consequent, we can get the negation of the antecedent. So since the antecedent is not A, we have to add a negation to that to get not A. So that's modus tollens from lines 1 and 5. And then we needed to conclude A, but we have a simple double negation rule that allows us to get rid of that. So that is double negation elimination. You could also write DNE. And that was applied to line 6. And our proof is done. I want to also illustrate that there's an alternative way of completing this proof. And that would be, we could assume not A, and that would be an assumption for indirect proof. Indirect proof tells us that if we assume the negation of a sentence and prove a contradiction, we can add the sentence itself. And since our goal in the conclusion is to get A, to prove it by indirect proof, we should assume not A. So by this, we can get not B by our normal conditional elimination rule applied to 1 and 3. And then, since we have B and not B, that gives us a contradiction, always justified by negation elimination. And that was lines 2 and 4. And an indirect proof ends when we have a contradiction. That allows us to add the sentence itself, A. So that was by indirect proof, lines 3 to 5. So this is actually a proof of the same sentence with slightly different rules that was one line shorter. This illustrates that there's not always one way to get to the conclusion, so sometimes you can try different things and see what works. And finally, I just want to show that I've gone back in here and filled in the lines to mark our subproofs so it's clear what our assumptions are and what the scope and continuation of the subproofs are. Now let's look at a second example, and this one is going to illustrate the law of excluded middle as well as one of the De Morgan's rules. So from if P then not Q, we're supposed to infer not Q and P. So it's helpful with an example like this or any of them to take a look at your premise and conclusion and think about what their structure is and what rules you might apply to them. So one thing I notice when I look at this conclusion is that that is actually the structure of one of the things we can prove with De Morgan's rules. So I'm going to make a guess here. I know that the last line of my proof is going to have to be the sentence I'm interested in proving, but I'm going to bet that the line before it is going to get me this by applying De Morgan's rules to whatever the line previous to this is. And I can get the negation of a conjunction from the disjunction of two negations. So notice that the connector is switched and the scope of the negation switched. That's what De Morgan's rules do. So I haven't numbered these lines. I don't know exactly what number they're going to be, but I'm going to guess that this will be somewhere near the bottom of my proof. This will be how it concludes, given how that conclusion looks. It might turn out that I'm wrong, but I'm going to say this is a reasonable guess. So if I'm right, I have to figure out a way to introduce this sentence. And one way to do so, since this is a disjunction, I'm going to have to use disjunction introduction. And it might be the case that I can get not Q and get not P or not Q, and I can get not P and get not P or not Q. So let me see what happens if I assume P. Now, I don't know why I'm assuming it yet, but I can fill that in later, see what rule I want to apply. If I assume P, I can get not Q, and that follows from conditional elimination from lines 1 and 2. Now that allows me to get this disjunction below, not P or not Q. So that's by disjunction introduction on line 3. So I'm going to say I want to close that subproof for now because I've gotten a sentence that I need later on in my proof. But I don't know what rule yet might allow me to move this sentence to the main body of my tree. There are a couple of rules that work with a secondary subproof, though. So one would be disjunction elimination. But I don't want to eliminate this disjunction. It's the one I'm trying to get. And this doesn't have a disjunction for me to eliminate. So that isn't going to work. I have this alternative, law of excluded middle. It allows me to assume not P and see if I can get this sentence. And I can do so pretty much directly. So by assuming not P, and this now is an assumption for law of excluded middle, where we assume P in one proof and not P in the other. So I can fill this in. Assuming not P immediately allows me to add not P or not Q. Again, by disjunction introduction, this time applied to line 5. So you can add the other disjunct in whichever direction you want. And this works perfectly for law of excluded middle. That rule says that if you can infer the same sentence from one sentence and its negation, you can add that sentence to your tree. So that means that this sentence that I thought I wanted to get is actually my line 7, and I got to it by law of excluded middle with 2 subproofs, one that ran from lines 2 to 4 and one that ran from lines 5 to 6. And then line 8 allowed me to simply apply De Morgan's rules to get this negation of a conjunction. And my proof is done. Rules like law of excluded middle and indirect proof, which don't tell you exactly what to assume for a particular connective, tend to be ones that are useful when you don't have a lot of assumptions to rely on, like in this, where we only had a single conditional to appeal to. Our last example is going to illustrate disjunctive syllogism, the last of the rules we need to cover, as well as another one of the De Morgan's rules. So our premises are if T, then A or B, the negation of A or C, and B if and only if C. Now, in our strategy, I suggested applying any rules that you can that don't require subproofs first. So we've got our premises, we've marked our conclusion. We take a look. This is a conditional, but we don't have the antecedent. We can't apply that right away. This is a biconditional, but we don't have either B or C, so we can't apply biconditional elimination yet. But in line 2, we have the negation of a disjunction. That allows us to apply De Morgan's rules, and De Morgan's rules are non-subproof rules. So from the negation of a disjunction, we get the conjunction of 2 negations. So we get not A and not C from not A or C. So that is De Morgan's applied to line 2. And now that we have a conjunction, we can actually apply more non-subproof rules. So we can get not A, and that's by conjunction elimination applied to line 4. And we can get not C as well by applying conjunction elimination to line 4. At this point, we have to reevaluate. There are no more non-subproof rules we can apply to 4. We can look back at our premise assumptions. So we've discharged all the assumptions we can get out of 2. We can kind of ignore 2 for now. And then looking at 1 and 3, again, we still don't have either side of the biconditional, so we can't apply biconditional elimination. And we don't have the antecedent T yet, so we can't use conditional elimination. Our purpose now should be to look to our conclusion. Our conclusion is the negation of T. Since we have a negated sentence, it is probably useful to use negation introduction. So if we want to introduce negation, we have to assume the sentence we want the negation of. So this is the negation of T, so we should assume T for negation introduction, and just mark that as an assumption. With T as our assumption for negation introduction, we can now use the first of our premises. So we have the antecedent, and we can get A or B. And that's by conditional elimination from lines 1 and 7. Now we have to consider, what can we do with the disjunction? One thing we could do would be to apply disjunction elimination. That's a rule we want to avoid using unless we absolutely have to, because it involves two subproofs. It's quite long and tedious. So we want to look and see if we can maybe apply disjunctive syllogism. That's another way we can get rid of a disjunction now. And it turns out we have the negation of one of our disjuncts at line 5. So disjunctive syllogism tells us that if we have the negation of a disjunct, then we can add the other disjunct on a new line. So that's DS for disjunctive syllogism from lines 5 and 8. And now that we have B as a sentence on its own, we have one direction of the biconditional, which is great. That allows us to infer the other side of the biconditional, C. So that's by biconditional elimination from lines 9 and 3. And now our tree, we should notice, contains C and not C. That means that we have proved a contradiction within this subproof. So we have to use negation elimination to justify that from lines 6 and 10. And that's great, because to conclude a subproof for negation introduction, we have to reach a contradiction. And once we do, we're allowed to infer the negation of the sentence we started by assuming. So we can infer not T, which is exactly what we wanted to prove. So our proof is complete. We just have to justify this and mark the extent of our subproof. So this is justified by negation, introduction, and the subproof ran from line 7 to 11. And then we just mark the extent of our proof. And with that, you now have some examples that illustrate more aspects of our strategy and ways to implement it, as well as our new rules: disjunctive syllogism, modus tollens, law of excluded middle, De Morgan's rules, and double negation elimination.